2.
Here we have wave equation recap, the second board that we're going to explore, really a continuation of what we just did. We did the hard work. We showed that the function f of z is a linear combination of these functions, exponential e to the j omega over vz, and the same with a different constant and a minus sign. Now, we substitute that back in, we have to our solution, we have to multiply by e to the j omega t, and combining exponents, we get these exponents here. Now what we're going to do is we need to simplify the math a little bit, and what we notice is we have omega over v in both of these expressions, but omega over v is just the phase velocity of the wave. It's v, it's a constant number. It doesn't depend on frequency. And so we know that k is equal to omega over v, or if you rearrange this, v is omega over k. In this case, there's no dependence of the velocity on the frequency. It's a constant. So now if we substitute in, we can see that we have k here and k here. And this is what we used in class. I just gave you this one to differentiate and show by simple differentiation, as you did in your groups, that this solves the wave equation. Well, now we have the complete analysis of the wave equation. We have the derivation of the solution, and we can see that this term is of the form g of z plus vt, and this is of the form h of z minus vt. If you need some further corroboration, let's look at this exponent here. And it is, the exponent is omega t minus kz. The j is factored out. So we can always, in this factor here, we can always take out a constant. So we'll take out minus k. And if we do that, we get z minus omega over k t. So this is the exponential. This is what you take e to after the j. So you stick a j in front. So you can see that this function, z minus omega over kt, omega over k is v, the phase velocity. So there we have a function of z minus vt. So we've really closed the loop between our intuitive result and the Maxwell wave equation and the solution, and find out they're basically the same. But we got the intuition first, and we did the detailed operations second, and they're the same. And that's what you want when you're doing physics, applied physics, and electrical engineering. Intuition first, confirmation with math second, and then second confirmation with computer models.